All right, let's talk about something we've all experienced, the electric bill. Have you ever opened one up and just felt completely lost, like you need a secret decoder ring just to figure out what you're paying for? Well, you are definitely not alone. Today, we're going to crack the code, digging into some really cool research that explains why our bills are so complicated and, more importantly, if all that complexity actually does any good. Right? It's a universal feeling. You see all these tiers and peak hours and different rates. It's enough to make your head spin. But what if I told you there's actually a method to all that madness? So here's the deal. This complexity isn't just there to confuse us. It's actually a tool that policymakers use to try and manage the entire energy grid. Think back to the energy crunch in parts of China in 2020. You had sudden cold snaps, coal prices were soaring, and the whole system was under massive stress. In moments like that, these complex pricing systems are designed to send us a signal, to nudge us to use a little less power when the grid is struggling the most. But do these nudges actually work? To figure that out, researchers zeroed in on a really unique experiment that ran in the Chinese city of Hangzhou a few years back, from 2009 to 2011. What made it so special is that they combined two different kinds of complex pricing systems at the exact same time. Okay, so the first system is called increasing block pricing, or IBP. The idea is pretty simple, really. Think of it like a staircase for your bill. The first block of electricity you use, your first step, is pretty cheap. But once you use a certain amount and step up to the next block, the price per unit gets higher, and so on. The goal? To make you think twice before you use a ton of energy. And then there's the second system, time of use pricing, or ToU. This one is all about when you use your power. During the day, from 8 in the morning till 10 at night, that's peak time, and electricity is more expensive. But in the middle of the night, during the valley hours, it's way cheaper. It's meant to get you to shift things like running the dishwasher or doing laundry to those off-peak hours. And here's where it gets wild. In Hangzhou, they mashed these two systems together. Just look at this table. It's not just that the price goes up when you cross those 50 or 200 kilowatt-hour thresholds. Nope. Within each of those tiers, you're also paying a different price depending on whether it's peak or valley time. It's a seriously complicated puzzle for the average person to try and solve every month. Which leads to the big question, right? Did it work? Did people see these price cliffs coming and carefully adjust their behavior to save a buck, just like a perfect economic model would predict?
Well, this is where the mystery starts. According to standard economic theory, you'd expect to see what's called a bunching effect. Basically, a whole lot of households should slam on the brakes right around that 200 kilowatt-hour mark to avoid jumping into that more expensive tier. But when the researchers looked at the real-world data, they didn't see that at all. The pattern was messy, it was spread out, so what gives?
This puzzle, this messy data, led the researchers to a brilliant and totally new idea. They realized that the old models were missing a crucial, real-world ingredient. They called it bill shock. And this quote from their paper really just nails it. It says that we cannot exert perfect control over final consumption. In plain English, that means real life isn't a textbook. We can't just perfectly dial in our energy use to the exact watt. We can try, we can have a plan, but, life happens. So what is this bill shock? It's that unavoidable gap between what you plan to use and what you actually use. The researchers had this great analogy. Imagine you're trying to fill a glass of water right to the very top, but you're doing it on a bumpy bus ride. You can aim perfectly, but a little bit of sloshing is inevitable, right? That random sloshing, that's bill shock. And we're not talking about a tiny little drop either. Their model found that because of this bill shock, the average household ended up using about 3 to 4% more electricity than they actually planned to. That small, random error adds up, and it's the key to why that data from Hangzhou was so messy instead of showing that nice, clean bunching effect. So, once the researchers built a new model that actually included this messy, human factor of bill shock, what did they uncover? Let's take a look at what it tells us about how people really react to the price of electricity. All right, so after all that complex modeling, the researchers managed to boil it all down to one single crucial number. Ready? Here it is, negative 0.7%. So what on earth does that actually mean? It means that in the long run, for every 1% you raise the price of electricity, people will cut back their total use by about 0.7%. This is what economists call price elasticity. And it proves that, yes, prices matter. People do respond. They just don't do it in the perfectly clean, robotic way that the older theories assumed. Now, this is where the story gets really human. The model showed that the pain from a price hike is not shared equally. It turns out that larger households, the ones with more gadgets and appliances plugged in, they actually felt less of a financial pinch from the price changes. But on the flip side, households with lower incomes got hit much harder. And of course, things like the weather play a huge role. A price hike stings a lot more during a brutal heat wave when you absolutely need that AC. The researchers also ran some what-if scenarios, like what if we changed where those price jumps happen? And they found a really clear trade-off. If you move that price kink to the left, meaning the higher prices kick in sooner, consumers end up worse off. But if you move it to the right and let people use more of that cheap electricity, their financial well-being improves. It's a really delicate balancing act for policymakers.
So after all of this, let's zoom out. What's the big picture takeaway for anyone trying to design the perfect, smart electricity pricing system?
Well, the answer is actually a little bit sobering. What this research ultimately suggests is that even though these complex systems seem really powerful on paper, the actual practical room for making them work better in the real world is surprisingly small. And here's why it's so tough. Policymakers are caught in this tricky balancing act. Let's say you lower prices to help people out. Okay, great. But then that just encourages everyone to use more energy. So to counter that, you have to shrink the size of the cheap tiers, which ends up hurting people's wallets all over again. It's this constant push and pull.
And this final quote from the paper just puts the perfect button on it. When you layer these complex systems on top of each other, the IBP and the ToU, you can get to a point where their effects just cancel each other out. The very tools that were designed to make the system smarter could end up making the whole policy, well, kind of useless.
Which brings us right back to our original question. We wanted to crack the code of our electric bills. And what we found is that maybe the complexity itself isn't the silver bullet we all thought it was. So if these incredibly intricate pricing schemes aren't the answer, what is? How do we build an energy future that's efficient, fair, and stable? That right there is the million-dollar question this research leaves us with. Thanks for tuning in.